Hello everyone, my name is Vinay Kumar. My topic is John von Neumann's contribution to computing and computer science. John von Neumann was a Hungarian-American mathematician, physicist, computer scientist, engineer, and polymath. Von Neumann was generally regarded as the foremost mathematician of his time and said to be the last representative of the great mathematicians. He integrated pure and applied science. John von Neumann made major contributions to many fields including mathematics, physics, quantum statistics, computing, statistics, and etc. He was a pioneer of application of operator theory to quantum mechanism in the development of functional analysis and a key figure in development of game theory and concept of cellular automata and the universal constructor and the digital computing. Von Neumann was a founding figure in computing. Von Neumann was invented in 1945 of the merge sort algorithm in which the first and second halves of an array are each sorted recursively and then merged. Von Neumann wrote the 23 papers long sorting program for the EDBAC link. On the first page traces of the phrase top secret, which was written in pencil and later erased and can still be seen. He also worked on the philosophy of artificial intelligence with Alan Turing when the later visited Princeton in 1930s. Recursive merge sort algorithm used to sort an array of 7 integer values. These are the steps a human would take to emulate merge sort top-down. You can see that there is an array of elements and then divided it into half and then divided them into halves and then arranged them in order, merging merging them into two, and then finally the array is arranged into an order by dividing them into two parts and then ascending arranging them in order and then merging them so that it can be arranged in order. Von Neumann's hydrogen bond work was played out in the realm of computing, where he and Stanislaw developed simulations on von Neumann's digital computers for the hydrodynamics computation. During this time, he contributed to the development of the Monte Carlo method, which allowed solutions to complicated problems to be approximated using random numbers. Von Neumann's algorithm for simulating a fake coin with biased coin is used in the software writing stage of some hardware random number generators. Because using lists of truly random numbers was extremely slow, Von Neumann developed a form of making pseudo-random numbers using the middle square method. Although this method has been criticized as crude, Von Neumann was aware of this. He justified it as being faster than any other method at his disposal, writing that anyone who considers mathematical methods of producing random digits is of course in a state of sin. Von Neumann also noted that when this method went array, it, it did so obviously unlike other methods which could be subtle incorrect. While consulting for the Moore School of Electrical Engineering at the University of Pennsylvania on the EDBAC project, Von Neumann wrote an incomplete first draft of report on the EDBAC. The paper accused premature distribution modified the patent claims of EDBAC. Designers J. Presper Eckert and John Mosley described a computer architecture in which the data and the program are stored in the computer's memory in the same address space. This architecture is the basis of most modern computers design. Unlike the earliest computers that were programmed using a separate memory device such as paper tape or plugboard. Although the single memory stored program architecture is commonly called von Neumann's architecture, as a result of von Neumann's paper, the architecture was based on work of Eckert and Bontley, inventors of ENIAC computers at the University of Pennsylvania. John von Neumann consulted for the Army's Ballistic Research Laboratory, most notably on the ENAAC project as a member of its scientific advisory committee. The electronics of the new ENAAC ran at 1/6 the speed, but this is no way degraded the ENAAC's performance since it was still entirely IO-1. Complicated programs could be developed and debugged in others English rather than the weeks required for plugboarding. The old DNIAC, some of von Neumann's early computer programs have been preserved. The next chip computer that von Neumann designed was the IIS mission at the Institute of Advanced Study in Princeton, New Jersey. He arranged its financing and the components were designed and built at the RCA Research Laboratory together. John von Neumann recommended that the IBM 701, nicknamed the defense computer, include a magnetic drum. It was faster version of the IIS mission and formed the basis for the commercial successful IBM 704. Stochastic computing was Stochastic computing was first introduced in a pioneering paper by John von Neumann in 1953. However, the theory could not be fully developed until the advances in computing of the 1960s, mostly through a series of simultaneous and parallel efforts in the US and the UK. By the late 1960s, attention turned to the design of special purpose hardware to perform stochastic computation. Hosts of these missions were constructed between 1960 and 1974. Stored program computer. Early computers such as IBM had no form of internal storage. All instructions and data were held one punch card, which could be fed into the IBM to process data in the 1960s, when the IBM was using calculations for performance to get astronauts into orbit and back, with the processing power of a modern-day toaster. Nowadays, computers typically use von Neumann's architecture, which reflects the idea of stored program concepts. Von Neumann architecture and the stored program concept works by machine code instructions and data are stored and loaded from memory into the processor to be executed in sequential order. Von Neumann architecture is used for general purpose machines where the instructions and data are held in the same memory location, that is our main memory or RAM. The von Neumann architecture uses the stored program concept where the instructions and data are loaded from main memory into the processor to be executed. On the other hand, hardware architecture follows the program concept where it takes into account the use of the memory unit, the both instructions and the data being held in the same address. This is going to work optimum speed at least to computing over the same data bus. In addition, one data bus may have an insufficient bus width for program instructions, that is increasing traffic due to program instructions having a greater word width. However, architecture is often used for specialist embedded computer systems with optimum speed priority for the system. This is a stored program concept in motion. Means that optical disk secondary storage with the code on. The code is uploaded into the main memory. The processor fetches records and executes the instruction from main memory to play game. Secondary storage, hard disk, USB, DVD, main memory, and processor. Von Neumann made major contributions to many fields including mathematics, physics, quantum mechanics, hydrodynamics. We covered hydrodynamics, mathematics, physics, quantum statistical mechanics, economics, game theory, computing. Von Neumann architecture, linear programming, self-replicating machines, stochastic computing, and statistics. Stochastic computing was first introduced in pioneering paper by John von Neumann in 1953. This is the stochastic computing pioneer. It was first introduced in 1953 by John von Neumann. most certainly through a series of simultaneous and parallel efforts in the US and the UK. By the 1960s, attention was turned to the design of the special purpose hardware to perform stochastic computation. A host of these missions were constructed between 1960. That's all about the John Woodman's contribution to the